The last time a storm on Earth reached the pressure, some models are now forecasting for Typhoon Bavi. The year was 1979. Yesterday, Bavi was a 60-mile-per-hour tropical storm. By this weekend, it is forecast to explode into a super typhoon aimed straight at the Mariana Islands, American soil, home to nearly 200,000 people. A few models are printing a pressure that would rival the strongest tropical cyclone ever measured. I will show you what is real, what is worst case, and why no aircraft will measure the truth in time. Yesterday morning, a tropical storm named Bavi was moving across the open western Pacific, with maximum sustained winds of about 60 miles per hour. On paper, at that moment, it was not remarkable. A broad, still organizing system far out over warm water, hundreds of miles from the nearest land. But it had already climbed from around 45 miles per hour to 60 in the span of a single morning, and nearly every forecast model and every official warning center agreed on what was coming next. This is the story of a storm that was almost nothing yesterday, and is forecast to become, within days, one of the most powerful tropical cyclones on Earth, aimed directly at American soil. Let me give you its position. At 6 o'clock in the morning, Coordinated Universal Time yesterday, the Joint Typhoon Warning Center placed the center of Bavi roughly 1,545 kilometers, about 960 miles, east of Andersen Air Force Base on Guam. The system was moving west-northwest at about 24 kilometers per hour, or 15 miles per hour, carrying 1-minute maximum sustained winds near 60 miles per hour. That is a tropical storm, not yet a typhoon. What matters is not where those numbers sit today, but the slope they are on. The storm was strengthening even as forecasters were writing the words to describe it. Bavi carries the designation 9W, the ninth tropical cyclone the Western Pacific has spun up this year that warranted a number. Names in this basin get assigned early, long before a storm becomes dangerous, and most of them never make headlines. The reason this one already has the attention of every warning center from Guam to Tokyo is not its present strength. It is the environment it is about to move into, and the direction it is pointed. The direction is the part that turns a weather story into a human one. The most likely track carries Bavi west-northwest, straight toward a small cluster of islands in the middle of the Pacific, islands that happen to be United States territory, home to nearly 200,000 American citizens. Those islands took a super typhoon just 3 months ago. And the forecast that every major agency is now publishing says the storm bearing down on them this weekend could be even stronger. That is where we have to start, because everything about this story is a race between how fast Bavi strengthens and how fast the people in its path can get ready. Right now, this morning, the storm is still out over open water, still gathering itself. By tomorrow afternoon, it will be a different animal, and by Sunday, it is forecast to arrive. Let me walk you through exactly what the forecast says, why the numbers are so alarming, and why one particular figure has forecasters using a phrase they almost never say out loud. The official forecast is where this stops being a routine tropical storm and becomes the biggest weather story on the planet. The Joint Typhoon Warning Center expects Bavi to strengthen slowly for the first stretch, and then enter a prolonged window of what meteorologists call rapid intensification, a phase where the storm's winds climb explosively over a short span of time. Their forecast brings Bavi to a peak as a super typhoon, with 1-minute sustained winds near 250 kilometers per hour, or 155 miles per hour, around Sunday, July 5th. The projected track carries the center just south of the island of Tinian late Sunday night into Monday morning local time. Let me put that number in context, because 155 miles per hour is not an ordinary typhoon. In the Western Pacific, a storm earns the label Super Typhoon when its 1-minute sustained winds reach at least 150 miles per hour, roughly the boundary between a high-end Category 4 and a Category 5 hurricane on the scale most Americans know. Bavi's forecast clears that bar, and the agency went further than the raw numbers. In its own discussion, the Joint Typhoon Warning Center noted the possibility that Bavi could become the strongest July typhoon ever to directly pass through the Mariana Islands since the beginning of reliable records. Not the strongest this year, the strongest for this month in the entire modern record. Now, there is a second major forecast center watching this storm, and its numbers look different at first glance, for a reason worth understanding. The Japan Meteorological Agency also expects Bavi to intensify, projecting it to become what it classifies as a very strong typhoon, with 10-minute maximum sustained winds near 110 miles per hour and a central pressure of about 925 hectopascals as it approaches the islands. If you're wondering why one agency says 155 and the other says 110, the answer is not that they disagree. It is that they measure wind differently. The American Center averages wind over 1 minute. The Japanese agency averages it over 10 minutes. A longer averaging window smooths out the peaks, so it always produces a lower number for the exact same storm. Both descriptions point to the same thing: a dangerous, high-end typhoon. The pressure figure is the one to hold onto. Central pressure is, in many ways, a truer measure of a tropical cyclone's raw power than wind speed, because it reflects the whole engine rather than a single gust. Lower pressure means a stronger storm. A reading of 925 hectopascals already describes a formidable, destructive typhoon. Keep that number in mind, because in a few minutes I'm going to show you the numbers that a handful of forecast models are quietly producing for Bavi, numbers that go far below 925, into territory the record books have not seen in almost half a century. As of this morning, the National Weather Service office on Guam had already flagged the increasing potential for a typhoon passage somewhere in the Marianas, even before formal watches or warnings were posted. When a local weather office starts using that language days ahead of a storm, it is telling the people who live there to stop waiting and start preparing, and it gets more serious from here. Here is the number I promised you. In the days after Bavi is forecast to pass the Marianas, a set of individual computer model runs, including solutions from the European forecasting model, one of the most respected in the world, have shown the storm's central pressure bottoming out somewhere between 871 and 883 hectopascals. To understand why that made forecasters stop and look twice, you need one piece of history. The lowest central pressure ever measured in a tropical cyclone anywhere on Earth is 870 hectopascals, set by Typhoon Tip in the Western Pacific in 1979. Tip was not only the most intense storm ever recorded, it was also the largest, with a wind field stretching about 1,380 miles across and peak winds near 190 miles per hour. So when a modern, credible model prints a pressure of 871 hectopascals for Bavi, it is placing this storm, in that particular solution, into the same sentence as the strongest tropical cyclone humanity has ever measured. That is the reason you're hearing the phrase, strongest storm on Earth, attached to a system that, as of yesterday, was a 60-mile-per-hour tropical storm. That is where the drama in this story actually comes from. But I have to be honest with you about what those numbers are and what they are not, because this is exactly the kind of figure that gets stripped of its context and turned into something it isn't. Those extreme pressure runs are outlier solutions at long range. Individual model forecasts reaching about a week into the future, which is the range where any single model is least reliable. They are not the official forecast. The official forecast, the blended and more conservative one that the warning centers actually publish, describes a dangerous super typhoon near 155 miles per hour, already a catastrophe for anyone in its path, but not a guaranteed world record. The honest way to hold this is to keep two ideas in your head at once. This storm could become historic, and we cannot yet be sure it will. Both are true. The tension between them is the story, and predictably, the moment those extreme model images started circulating online, so did the theories. Some claimed the storm is being manufactured or steered, that some facility is building a monster on purpose, that collapses the instant you look at the energy involved. A mature typhoon releases heat energy on the order of hundreds of times the entire world's electricity generation every hour it exists. No human installation creates or steers a heat engine the size of an ocean. The storm's path is set by large-scale steering currents that forecasters can see and map. Others claim the extreme model images prove a record storm is being hidden. That gets it backwards. Those runs are public, shared openly, which is the opposite of a cover-up. A single model run at a week's range is one possible future among many, and the official centers publish calmer numbers precisely because those long-range spikes are so unreliable. The science here is not hidden. It is just truly uncertain, and uncertainty is harder to sell than a conspiracy. What is not uncertain is the direction. Whatever Bavi's true peak turns out to be, the forecast track points it at a specific, small, and already wounded target. So let me show you exactly who is in the path. The target is a chain of islands most Americans could not find on a map, but they are as American as any state. The Mariana Islands sit in the Western Pacific, and they include Guam, a United States territory and home to a major Air Force base and naval presence, along with the Commonwealth of the Northern Mariana Islands, which covers the islands of Rota, Tinian, and Saipan. Guam alone is home to roughly 150,000 people. The Northern Marianas add about 47,000 more. That is nearly 200,000 United States citizens living directly in the forecast path of this storm. Let me be clear about what makes these islands so exposed, because it is not the same as a hurricane threatening the Gulf Coast. These are small islands. When a mainland city faces a hurricane, people can drive inland, away from the coast, away from the storm surge, to somewhere the winds are weaker. On an island only a few miles wide, there is no inland. There is no interior to retreat to. If the eye wall, the ring of the strongest winds surrounding the calm center, passes over Saipan or Tinian or Guam, The entire island is inside the worst of the storm at once. Everyone on it experiences the peak. That is the geography Bavi is aimed at. Exactly which islands take the hardest hit is still uncertain, and it comes down to a split between the models. Some guidance, including the American model, nudges the center directly over Tinian and Saipan in the north. Other guidance, including the European model, trends the track farther south, which would bring the core closer to Rota and Guam. That difference of a few dozen miles is the difference between which communities take the eye wall and which take the merely severe edge. And here is the part that matters, even if the track shifts. Bavi is forecast to be a large storm. Even the islands spared a direct eyewall passage would still face damaging typhoon-force winds and torrential rain. Nobody in this chain gets to sit this one out. The rainfall alone is its own threat. Forecasters are calling for totals over 250 millimeters. That is roughly 10 inches of rain, with locally as much as 18 inches possible on whichever islands take the brunt. On steep island terrain, that much water in a short time means flash flooding and landslides layered on top of the wind damage, and the timing gives the islands almost no room. Local forecasters are urging that all preparations be complete by tomorrow afternoon, Saturday, because conditions are expected to deteriorate through Sunday and into Monday as the core arrives. That is not a week of warning. That is a matter of a day or two. So this is the situation. Nearly 200,000 Americans on islands with nowhere to hide sit in the path of a storm forecast to be at or near super typhoon strength, with less than 48 hours to get ready. And to understand how a 60-mile-per-hour tropical storm becomes that monster in 3 days, you have to understand what is about to happen to Bavi over the water in between. Rapid intensification is the phrase at the center of this forecast, and it has a precise, formal definition. A tropical cyclone is said to be rapidly intensifying when its maximum sustained winds increase by at least 30 knots, about 35 miles per hour, and within a single 24-hour period. That is the official threshold. Now look at what Bavi is forecast to do. Climb from about 60 miles per hour yesterday to around 155 miles per hour by Sunday. That is roughly 95 miles per hour of strengthening in about 3 days. It does not just cross the rapid intensification line, it leaves it far behind. Let me explain how a storm pulls that off, because it is not random. It requires a specific set of conditions to all line up at once, and Bavi is about to move into the one part of the ocean where they do. A tropical cyclone is a heat engine. It runs on warm ocean water, converting the heat of the sea surface into the wind and rain of the storm. To intensify explosively, it needs several things stacked together. Very warm water at the surface, generally between 29 and 31 degrees Celsius, a thick layer of that warm water extending well below the surface, so the storm's own churning does not drag up cold water and choke itself. A low wind shear, meaning the winds high above the storm are not blowing the top off of it. Plenty of moisture in the middle levels of the atmosphere, and strong outflow at the top, venting the rising air like a chimney. When all of those align, a storm can strengthen faster than almost anything else in nature. The stretch of ocean ahead of Bavi, the Philippine Sea, supplies every one of those ingredients at the same time. It is, functionally, a factory for the strongest storms on the planet. And that brings us back to the pressure number, because there is a direct physical link between how low a storm's central pressure drops and how hard its winds blow. The greater the difference between the calm, low-pressure center and the higher pressure of the surrounding air, the more forcefully air rushes inward, and the faster the winds spin. That is why a storm in the 880s would be so much more dangerous than one at 925. The pressure gradient driving the wind would be far steeper. It is also why forecasters watch the pressure trend as closely as the wind. It is the tell for what the storm is about to do next. History says we should take the explosive scenario seriously. Storms in this basin have repeatedly overperformed the models. As recently as 2015, Hurricane Patricia in the eastern Pacific bottomed out near 872 hectopascals, right up against Tip's all-time record, during a burst of intensification so fast it stunned the forecasters watching it. The ingredients that produced Patricia are the same ingredients now sitting in front of Bavi. None of this guarantees a record, but it explains, in plain physical terms, why the models can even imagine one, and why the warning centers are treating this storm with the seriousness they are. To see what that means on the ground, we have to look at the islands themselves, because they have been here before, and far more recently than you might think. The people of the Mariana Islands are not facing this as an abstraction, and they are not facing it fresh. Just 3 months ago, in April of 2026, Super Typhoon Sinlaku struck the same region, the same small chain of islands now in Bavi's path. Sinlaku crippled power, tore up roads, and damaged key infrastructure across Saipan and Tinian. The recovery from that storm is not finished. In many places, it has barely begun. And now, roughly 11 to 12 weeks later, a second storm of the same class, potentially an even stronger one, is bearing down on the same ground. Think about what that actually means for the people living there. When infrastructure is already damaged, a community's ability to withstand the next blow is lower, not higher. Temporary repairs come apart in high wind. Tarps over damaged roofs peel away. Power grids that were patched back together after April are more fragile, not more robust. Debris that has not yet been cleared becomes projectiles. Every storm is harder to endure when it lands on top of the wreckage of the last one, and Bavi is forecast to do exactly that. This is what makes the forecast numbers concrete. It is one thing to talk about 155 miles per hour and 883 hectopascals as figures on a map. It is another to remember that the map is pointed at communities of teachers, nurses, kids, and grandparents, nearly 200,000 of them, who spent the spring cleaning up from one super typhoon and are now boarding up for the next. For them, this is not the strongest storm on Earth in the abstract. It is the second monster in a single season, aimed at a home that has not finished healing. 2 storms of this intensity hitting the same tiny targets in one season is also, statistically, unusual. Even here, in the most active tropical basin on the planet, small islands are small targets. For the atmosphere to thread 2 super typhoon-class systems onto the same few square miles within a single spring and summer is the kind of run of bad luck that would be hard to believe if it were not happening in real time. It speaks to how active this basin has become, and that is not a coincidence. It ties directly to the water these storms are forming over. The same warm ocean that is priming Bavi right now. Regular viewers will remember that just over a week ago we tracked another super typhoon in this same basin, one that recurved toward Japan and its southern islands. That is not a separate story from this one. It is the same ocean, the same overheated engine, producing monster after monster in a matter of weeks. The Western Pacific is lit up. And to understand why this particular stretch of sea is manufacturing the strongest storms on the planet right now, and why we cannot be fully sure how strong they will get, we need to look at the water itself. The water Bavi is moving over is running warm, warmer than normal across a broad stretch of the tropical Pacific. One way scientists track this is the Oceanic Niño Index, a measure of sea surface temperature in a key region of the equatorial Pacific. Right now, that index sits at about plus 0.48 with a warming trend, just below the plus 0.5 mark that would formally signal El Niño conditions. In the region Bavi is crossing, sea surface temperatures are running between 29 and 31 degrees Celsius. And that warmth is not just skin thin. It reaches well below the surface, which is exactly the fuel supply a storm needs to keep intensifying without choking itself on cold water. This is the same warmed ocean that has been feeding record heat and extreme weather in other parts of the world at the same time. That is worth saying carefully. This is not one weather event causing another. It is many events drawing on the same underlying condition, an overheated ocean. Warming seas raise the theoretical ceiling for how strong a tropical cyclone can get, and the evidence increasingly suggests they are raising the share of storms that undergo rapid intensification, the explosive strengthening Bavi is forecast to do. The science is more confident about the intensity trend than about whether the total number of storms is changing. Bavi is best understood not as proof of anything by itself, but as one storm behaving exactly the way a hotter ocean would lead you to expect. And the hotter the water, the higher the ceiling that models like the ones now printing those record-flirting pressures are reaching toward. The environment in front of Bavi is not just favorable for a strong storm, it is close to optimal for the strongest kind. That is why the forecast is what it is, and it is also why the honest answer to how strong it will get is harder to give than you might think. Here is the part of this story that surprises most people. For all the precision in those forecasts, the 155 miles per hour, the 925 hectopascals, no one is actually flying into Bavi to measure it. In the Atlantic Basin, when a hurricane threatens the United States mainland, specially equipped aircraft fly directly into the storm and drop instruments through the eye to measure the pressure and winds by hand. In the Western Pacific, that routine reconnaissance does not exist. There are no hurricane hunters out there. Every intensity estimate for Bavi, every number I have given you, comes from analyzing satellite images from far above, using a technique that infers a storm's strength from the pattern and temperature of its clouds. That technique is good. It is decades refined, and forecasters are skilled at it. But it is an estimate, not a direct measurement, and it carries real uncertainty in both directions. The true peak intensity of a storm like Bavi may never be directly measured at all, and that is the strange, unsettling core of this whole story. The strongest storm on Earth may be taking shape right now, aimed at American soil, and the world will largely have to infer its true power from the way its clouds look from space. We may not know exactly how strong Bavi was until long after it has passed, if we ever know precisely at all. That uncertainty is not a reason to relax. It is the opposite. When you cannot measure the ceiling, the responsible move is to prepare for the high end of what is credible. The official forecast already describes a dangerous super typhoon. The outlier models whisper about something historic, and no instrument in the sky can yet tell the islands which one is coming. So the only rational response for the people in the path is to prepare for the worst version and hope for the one they can survive most easily. Which brings us to what happens next. The immediate future is the Marianas this weekend. If the forecast holds, Bavi reaches super typhoon strength and passes through or just south of the island chain late Sunday into Monday, local time. That is the moment of maximum danger for nearly 200,000 Americans, and it is now less than 2 full days away. Everything before then is preparation time, and it is running out. But Bavi's story does not end at the Marianas. If the storm survives its island passage intact and moves on into the open Philippine Sea, it moves over more of that same warm water. And it could keep strengthening. That is, in fact, exactly where those extreme model runs, the ones flirting with the all-time pressure record, place the storm's lowest pressure. In the days after the Marianas, out in the open water between the Philippines, Taiwan, and Japan. Which means the Marianas may not be the last chapter. Depending on the position of a steering ridge of high pressure and the timing of an approaching weather front, Bavi could become a longer-range threat to Luzon in the northern Philippines, to Taiwan, and to southern Japan in the following week. Whether it curves away or drives on depends on when it makes its turn, and that is still days from being settled. There is also more than one system in play. A separate tropical disturbance near the Philippines is forecast to lift toward China, spreading heavy rain across the region and feeding a weather front near Taiwan and southern Japan. The point is not that second system by itself. The point is that the entire western Pacific is active at once. Bavi is the headline, but it is forming in an ocean that is producing storm after storm, which is the real story underneath this one. Over the next 48 hours, a few specific things will tell us which way this goes. The first is the intensity trend. Whether Bavi actually enters the rapid intensification window the models are forecasting, and how fast the pressure falls once it does. If that pressure starts dropping quickly today and tomorrow, it is confirmation the explosive scenario is underway. The second is the track. Watch whether the official forecast nudges north toward Tinian and Saipan, or south toward Rota and Guam, because that shift decides which communities take the eyewall. The third is the arrival of formal watches and warnings from the Guam Weather Office, which were already looking increasingly likely as of this morning and should be posted soon. Let me leave you with the honest bottom line because it is both alarming and uncertain, and you deserve both halves. The official forecast calls for a dangerous super typhoon near 155 miles per hour, bearing down on United States soil this weekend. That much is already serious enough to demand action from everyone in the Marianas. A minority of extreme model runs raise the possibility of something the planet has not seen since 1979, though that remains a possible ceiling, not a promise. And because there is no aircraft flying into it, we may watch this entire event unfold through satellite eyes alone. The islands cannot wait for a certainty that will not arrive in time, and neither can we. Preparations in the Marianas need to be finished by tomorrow afternoon, and the rest of us should be watching this storm closely. Because by Sunday, we will know whether Bavi became the monster the models fear, or the near miss the islands are praying for. We will be tracking it every step of the way.